Hello guys, welcome to Ferdinand Tutorials. I hope you're doing. Hello guys, welcome to Ferdinand Tutorials. I hope you're doing well, each and every one of you. To here, happy weekend. I hope everything is going well on your own end. So in this video, I just want us to focus more on the fundamentals of chemistry. I hope you can hear me. So I want us to focus more on the fundamentals of biochemistry. There are stuff I really want us to know more about. Biochemistry generally is biochemistry is an interesting topic. Are we together now? So there are stuff I want us to learn. My camera is disturbing me. Let me fix it, please. Give me a minute. All right. This should be okay. Okay, this should be good. Okay, so yeah, so I said that as undergraduates of biochemistry, there are topics that you should try as much as possible to understand. Say for instance, you just got admission to study biochemistry, maybe this week or next, and then the next thing that individual will try as much as possible to talk to you will be, okay, welcome to study biochemistry. Now, what are the topics that you should be looking at? Are we together? Now, there are important topics that you should be looking at, that you should get used to. Are we together? Now these topics will help you get more used to the course. Biochemistry is an amazing course. As I've always said, I'm one of the advocates of this biochemistry. I love the course so much. Are we there now? Not just because I studied it as an undergrad, but I've seen the untapped opportunity, untapped potential that this course genuinely has. Are we together now? So what am I going to do here? I'm going to try as much as possible to make you to understand that. So now you've got an admission to study biochemistry, or you've been studying biochemistry as an undergraduate, year 1 or year 2. Now there are fundamentals of this particular course called biochemistry that you should know. If you have a book, write them down. Now there are 4 important biomolecules or fundamentals that you should know. Now, first of the biomolecules is what we call carbohydrates. We have what we call carbohydrates. Are we there now? Now, beyond carbohydrates, we have what we call proteins. Are we there now? Now, from protein, we have lipid, and we have nucleic acids. So now, these are the 4 biomolecules or fundamentals of biochemistry. Now, every other thing that we're doing in biochemistry, try as much as possible, to revolve around these 4 important biomolecules. Now, we usually call them biomolecules because they are biological molecules that are found in the body of a living organism. Hey, hello, Clark. How are you doing? I hope you're okay. Nice to have you here. Now, we say that these particular biomolecules are essential in the body of a living organism. Now, an organism cannot grow, an organism cannot advance without understanding this particular biomolecules. So, what I'm trying to, explain in this scenario is this, as a biochemistry student, you need to understand those biomolecules. Just as I've said, we have carbohydrates, we have protein, we have nucleic acids, and then we have lipids. Now, first of all, I want to start with carbohydrates. If you are watching, I greet you all. Please like this video so that others can also watch this video. YouTube can recommend it to other viewers. So I was saying something about carbohydrates. I said that in carbohydrates we have what we call monosaccharides, we have disaccharides, we have oligosaccharides, and we have polysaccharides. Are we there now? So as an undergraduate of biochemistry that recently gained admission to study the course, or you're in your first year, second year, or even third year studying the course, now you should understand something. You should understand that this particular biomolecule, which is carbohydrates, there are 3 important types, and then the 4th one, which is polysaccharide. But when we begin to look at monosaccharide, which is the number 1. Now in monosaccharide, what we are trying to look at is that we're looking at simple sugars. Are we together now? Monosaccharides are called what? Simple sugars. Now, under these monosaccharides, we begin to look at, as a biochemistry student, the monosaccharide we are looking at, starts from 3 carbon sugar. When we're talking about carbohydrates is more like a hydrated carbon. That's why when we're writing the molecular formula of carbohydrates, we write CnH2, O, or in brackets N. N indicates the number of carbon atoms. So in carbohydrates, for monosaccharide, we start with carbon 3, carbon 4, carbon 5, carbon 6, and carbon 7. Now carbon 3 are called trioses. Carbon 4 are called tetroses. Carbon 5 are called pentoses. That's carbohydrate that have 5 carbon atoms, we call them pentoses. Carbohydrate that has 6 carbon atoms, we call them what? Hexoses. Carbohydrate that have 7 carbon atoms, we call them what? Heptoses. Are we together now? Now, understanding this monosaccharide, we try as much as possible explain to us that even though we have, monosaccharide sugars, right? Monosaccharide, like triosis, tetrosis, pentosis, hexosis, and heptosis, it will try as much as possible to help us understand that we have what we call, aldehyde sugars and ketone sugars. Now, what is the difference between aldehyde sugars and ketone sugar? That's why I ask you to write down. I will then make sure you write these things down. Follow suit. I'm seeing your comments. If you have any question, please try as much as possible to follow suit. And if you have a particular topic that you're finding difficult to understand, let me know too. I will try as much as possible to explain them maybe subsequently. I will then. That's why we call this a weekly biochemistry workshop. I will then. After here, next week we'll be here again to talk about biochemistry. So as I was saying, I said that under monosaccharide, we have what we call aldehyde sugars and ketone sugars. Are we there now? Now, when we're talking about aldehyde sugars, what are aldehyde sugars? Now, aldehyde sugars are carbohydrate that has aldehyde functional group. Are we there now? We call them aldose sugars. So they are carbohydrate that has aldehyde functional group. We have ketone sugars. Ketone sugars are carbohydrate that have what? Ketone functional groups. Are we together now? So in this understanding of monosaccharide, I want us to try as much as possible to see that, even though we have carbohydrate that 3-carbon sugar like tetrotriosis, carbohydrate 4-carbon sugar, tetrosis, 5-carbon sugar, pentosis. Now examples of triosis, we have what we call glyceraldehyde. Are we there now? Examples of tetrosis, we have what we call erythrose and erythrulose. Examples of pentose sugars, we have begin to have what we call ribose and deoxyribose. Are we there now? Now, examples of hexose sugar. Hexose is carbohydrate with 7 carbon atoms. Examples of hexose sugar, we begin to have what we call hexose sugar. We begin to have what we call glucose, mannose, galactose. Are we there now? Those are carbohydrate with 6 carbon sugar, so we call them hexoses. Are we together now? We also have fructose. Now, these are monosaccharide. Are we together now? Now, we also have what we call a disaccharide. Now, in disaccharide in this scenario now, we're still talking about carbohydrate though. In disaccharide in this scenario now, we're looking at when we have this simple sugar, 2 monosaccharide units, try as much as possible to combine together or merge together. They form a disaccharide. Are we there now? Now, there are 3 important disaccharides as an undergraduate of biochemistry, like a newly admitted student that you should know. Are we together now? Now, there are, generally 3 important, disaccharides that we should understand and know. And then we begin to look at what we call, your lactose, we begin to look at your sucrose, we begin to look at your maltose. Hey, Chris, good day. Now, we begin to look at these 3 important, disaccharides. Are we together now? Now, so if we come to maltose, maltose are disaccharides that are formed. Are we there now? When we have 2 monosaccharide units joined together. Now, which monosaccharide units are we talking about? Now, the monosaccharide unit that we are focused here is glucose plus glucose. So when we have 2 glucose units combined together, they are going to form what we call a maltose sugar, maltose. Are we there now? So maltose is formed when we have 2 glucose units. Now, we also have another disaccharide, which is what? Lactose. Now, how is lactose formed? Lactose is formed when we have glucose plus galactose. Are we there now? That's how lactose is formed. Lactose is, more like a milk sugar. Are we together now? That's lactose. You've seen individuals talk about lactose intolerance and all that. Is Oyibo disease, not Nigerian disease. I've not actually seen an individual that said that one of the disease they are lactose intolerant. I don't know. I've not seen a Nigerian that have said that. If you've seen, let me know in the comment section. Maybe it's possible. Maybe because I've not seen. Do you understand? But I've usually seen in the movie where people say, I'm lactose intolerant and all. I would do that. So lactose as a disease, lactose as a sugar, is a disaccharide that is formed when we try as much as possible have, say, we have glucose plus galactose. I would now combine together, they form a lactose. Now the last, disaccharide there is sucrose. I would know. Now sucrose is a sugar that is formed when we have glucose plus fructose. I would know. Fructose is a monosaccharide. All these are monosaccharide. I would know. So in a nutshell, what I'm trying to insinuate is that, these are carbohydrates. I started with explaining that under carbohydrates, we have what we call monosaccharide, disaccharide, oligosaccharide, and polysaccharide. I've explained monosaccharide that they are simple sugars. They start with 3-carbon sugar like triosis. Example of triosis is glyceraldehyde. Tetrosis, carbohydrates with 4-carbon sugar. Examples of tetrosis, we have what we call erythrose and erythrulose. We have what we call 5-carbon sugar. Under 5-carbon sugar, they are called pentoses. Example of pentosis, we have ribose and deoxyribose. We have hexoses. Under hexoses, there are 6 carbon sugar. With an examples of hexoses, we have glucose, galactose, mannose, and fructose too. So we move on to disaccharide. I explained disaccharide. I told you that in disaccharide we have maltose, lactose, and sucrose. And I've explained, I told you that for maltose to be formed, we must have 2 glucose units combined together. And then what hosts these 2 glucose units? We call a glycosidic bond. So for disaccharide, oligosaccharide, and polysaccharides to be formed, a glycosidic bond must hold them together. Are you getting what I'm saying? So in this scenario now, for disaccharide that we have maltose, glucose plus glucose, lactose, glucose plus galactose, sucrose, which is glucose plus fructose. Now move on to oligosaccharides. Now oligosaccharides are formed when we have monosaccharide from between 3 units to 10 units of monosaccharides. So that means for a particular sugar to be called an oligosaccharide sugar, that sugar must have at least 3 molecules of monosaccharide up until 10 molecules of monosaccharide. Are we there now? Example is what we'll begin to look at what we call maltotrioses. Are we there now? Maltotrioses is an oligosaccharide. Bex91, hello. I hope you are good. Yeah, and if you're not subscribed to the channel, please hit that subscribe. Just like this video so that YouTube can recommend this video to other young science students and also, that is pretty what we're doing here, right? So I was trying to say something. I said that, when we begin to look at, oligosaccharides, we're looking at, carbohydrates that moves up to from 3 to, 10 sugar units. Do you understand? Now, 3 to 10 sugar units in this scenario, we're looking at example is maltotrioses. Are we there now? Now, we'll move on to polysaccharides. In polysaccharides are more like, they are complex sugars. Polysaccharides are the, polymers of this particular, biomolecules. Are we there now? I told you that we have 4 important biomolecules. We'll look at them as we continue. In today's session, I just want us to focus on carbohydrates. In our next session, we'll focus on another biomolecule. We'll be taking it one after the other. Are we together now? So work with me. So today I've explained, carbohydrates. I told you that there are, 4 different types of carbohydrates: monosaccharide, disaccharide, oligo, and poly. I've explained mono, I've explained di, I've explained oligo. Now in polysaccharides are complex sugars. Are we there now? Now what makes them complex? What makes them complex is that, they combine the simpler, units of this particular sugar to form the advanced form. Are we there now? So we cannot have a polysaccharide without, the minute forms. I don't know if you're getting what I'm saying. So what I'm trying to insinuate is that for us to have a polysaccharide, we must have, smaller units of monosaccharides combined together in adequate amount, in huge number. So that means polysaccharides cannot be formed when we just have 2 glucose units or 3 or 4 or 5. No. Here we're talking about hundreds of combination of glucose units. That is how polysaccharides are formed. So in this scenario now, in polysaccharide, the example we have what we call glycogen. Glycogen is an example of a polysaccharide. Are we there now? You know what is glycogen? For instance, when we eat excessive, amounts of foods that are rich in carbohydrate, the excess sugar in the body is stored in the liver muscle as glycogen. That glycogen is a polysaccharide. When we have monosaccharide, varying amount of monosaccharide that are stored in the body, are we there now? They are stored as glycogen. So glycogen is like a storage unit for carbohydrate, and it's a polysaccharide. And in plant, another storage unit for carbohydrates in plant is called starch. Are we there now? Starch is to plant what glycogen is to animal. Both of them are polysaccharides. I hope you are following. If you are following, let me know in the comment section. I want to know that I'm talking with scientists, undergrads, are we there now? Science lovers, people that love science. Are we together now? So what I'm trying to insinuate is that, we can actually have a polysaccharide without talking about, varying units, hundreds and thousands of units of sugars. So when you consume, an excessive amount of maybe rice, what are the foods that are rich in carbohydrates? Let me know. We have rice, we have beans, we have potato, sweet potato, yam and all. So when you consume them in excess, what happens is that, first of all, enzyme will act on them. We have what we call digestive enzymes. Are we there now? Now, digestive enzymes are, biological enzymes that try as much as possible to help the food to digest. Are we there now? They act on food, they masticate, they break down the food into smaller molecules. Are we there now? Under digestive enzymes, we begin to look at amylase, we're going to look at proteases, we're going to look at lipids, we're going to look at nucleases. They are all digestive enzymes. Are we together now? So we're not going deeper there. So when you consume those particular carbohydrates rich food, what happens is that the body breaks them down into simpler components. Are we there now? So that it will be easier for you to digest. But after digestion, you begin to see that you are filled up. But because you don't want to throw the food away, you continue ingesting more and more food. Now, the more food you ingest, what happens in your body is that your body tries as much as possible to store those particular food in your liver muscle, because it's now excessive carbohydrate. Your body will not store that particular carbohydrate in your liver muscle, because already I want you to understand something. There is a particular endocrine gland called pancreatic gland. Now, what pancreatic gland does is that pancreatic gland produces two important hormones, insulin and glucagon. And these two important hormones regulate blood sugar. Are you getting what I'm saying? Insulin and glucagon. Are we there now? Let's look at insulin, for instance. What insulin does is that it tries as much as possible, to control, the amount of sugar that enters into the blood. Because when we have excessive sugar in the blood, that's when we have diabetes. Diabetes is not when you have excessive sugar in your body. Diabetes is when you have excessive sugar in the blood. So insulin tries as much as possible to regulate the amount of sugar that enters into the blood. That's insulin as a hormone. Are you getting what I'm saying? So in this scenario now, when we have that particular food, carbohydrate like your rice, yam, you've consumed it a whole lot of time. Now, what happens is that as the digestive enzyme breaks it down, now the nutritive part will now enter into the bloodstream. Are we there now? That is when we now have what we call pulmonary circulation and systemic circulation. Are we there now? In your blood, there's what we call pulmonary circulation and what we have systemic circulation. Are we there now? Now, when those nutrients enters into your blood will now carry those nutrients around the body. Are we together now? So insulin will continue to regulate the sugar that enters up until it's enough. Insulin will prevent extra sugar from entering. Now, those extra sugar that you've consumed, what will happen is that they will be stored in your liver muscle as glycogen. So glycogen is a storage unit of sugars in the body of an animal, not plant. And that glycogen is what? A polysaccharide. Now, for starch is actually a storage unit of that particular carbohydrate in plants. And under starch, that's when we begin to look at amylose and amylopectin. Are you getting what I'm saying? Those are two divisions of starch, amylose and what? Amylopectin. So in this particular conversation, what we are generally looking at today is carbohydrates. And so I've explained monosaccharide, I've explained disaccharide, I've explained oligosaccharide, and I've explained what? Polysaccharides. I don't know if you're getting what I'm saying. Now, having understood, this simpler form of, monosaccharide. Now, how is it that it is called a biomolecule? What makes carbohydrates a biological molecule? That's the question that we have to answer. Because you can't just wake up and say, carbohydrate is a biomolecule. What is the reason that backs this particular assertion that carbohydrate is a biomolecule? Now, one of the reasons why we say that carbohydrate is a biomolecule now is because of its complex nature. Now, when we're talking about biomolecules, in biomolecules, we have what we call monomers and polymers. For every biomolecule, from lipid to nucleic acid to protein and then to carbohydrate, they have what we call monomers and polymers. Please, if you've not liked this video, like the video so that YouTube can recommend this video to other young students too, so that they can watch and learn as you are learning too. Isn't that a lovely thing? Of course it is. So I said that what makes carbohydrates a biomolecule is because it has what we call a monomer and a polymer. Are we together? Now the question is, what is the monomer of carbohydrates? Now the monomer of carbohydrates is what we call monosaccharides. Just as I've said, they are simple sugars. Are we together now? So the monomer of carbohydrates are what? Are monosaccharides. Now what are the polymers of carbohydrates? What do you think? Which one is the most complex in that carbohydrate? It's polysaccharides. So the polymer of carbohydrate is what? Polysaccharide. The monomer is monosaccharide. So for every biomolecules that we have, that you see, you begin to see that these biomolecules have what we call monomers and polymer. Now until we have the combination of monomers, when they come together, and they are held together by a bond, that's when they can form what? A polymer. Are you getting what I'm saying? So that is that about why carbohydrate is also about molecules. And in addition to that is essential in the biological formation, in the biological interaction of organisms. Understanding of carbohydrates helps us to know when an individual is infected with diabetes. Are we there now? Diabetes 1, diabetes 2, and no. I don't know if you're getting what I'm saying. And then it's also understanding of carbohydrate that helps us to know the role pancreatic glands play. Are we there now? Now, let me digress a little bit. Generally, in your basic biology, they taught you about pancreatic gland. And then they said that pancreatic gland can act as an endocrine gland and also as an exocrine gland. Now, when we're talking about endocrine and exocrine, in endocrine gland are also called ductless glands. Are we there now? Why are they called ductless glands? They are ductless glands because they don't have ducts. And endocrine glands usually produces hormone, while exocrine gland does not produce hormone, rather they produce secretions in the body of a living organism. Now, example of exocrine gland, we have your sweat gland. Are we there now? We have your sebaceous gland. Those are exocrine gland. Are we there now? You have your lacrimal gland. Those are exocrine gland. We also have pancreatic gland as exocrine gland. When we come to endocrine gland are, endocrine gland here in this scenario, we're looking at, your pancreatic gland, we're looking at, pituitary gland. Are we there now? Well, excuse me, we're trying to look at, the ova. They are all what? Endocrine gland. Are we there now? Thalamus. Now, in thalamus is located in the region of your brain. Are we there now? So when we begin to look at pituitary gland is, that particular gland that is located within the region of your, thalamus of your brain. So pancreatic gland. Oh, Salome, how are you doing? Good day. Now, pancreatic gland is the only gland that acts as, both endocrine and exocrine. Are we there now? So understanding of carbohydrates, which is a biomolecule, helps us to know that, okay, there are roles of this particular gland that regulates blood sugar. So in pancreatic gland produces the insulin and glucagon, which controls blood sugar. One helps to prevent diabetes, one causes diabetes. Do you understand? It's not like it causes it, intentionally, but it increases the reabsorption of, sugar by the blood, which is glucagon. While insulin tries as much as possible to limit, control, suppress, the amount of sugar that enters the blood. But if you come to, pancreatic gland as an exocrine gland, pancreatic gland as an exocrine gland is more like, when it tries as much as possible to secrete enzymes. Are we there now? Now, we have what we call digestive enzymes. In your basic biology, they explain that to you now. Digestive enzymes that break down, complex food substance into simpler food substance. Of course, without digestive enzymes, our food cannot digest. I know you've eaten this morning, Salome and others. Abi, good. So if you don't have digestive enzymes, the food will not break down. So pancreatic gland as an exocrine gland secretes enzymes. Enzymes like, proteases, which act on protein, amylases, which acts on carbohydrates, lipases, which acts on lipids. So those are, what we need to understand. That's the role of carbohydrates and pancreatic gland. Are we there now? So that means understanding these particular biomolecules helps us to, know that there can be a disease that can arise. Are we there now? So as an undergrad of biochemistry or as a young science lover, you need to know that carbohydrate is not just it's not a class of food per se. Are we there now? Carbohydrate is a biomolecule, biological molecule, macromolecule, important molecule in the body. Are we there now? That you should know, that you should study. Are we together now? So I've given the background explanation of this carbohydrate. So if you didn't start from the beginning, maybe when I end this slide, make sure you go back, watch through it again. We've said some important stuff. And for each particular conversation we have here, Salome, you've not eaten. Chris, you've not eaten. Why now? Why haven't you eaten? Why haven't you eaten? Are living close to me? I cooked a whole lot of food. You would have come and join me and eat. But you're living in another state. So don't worry. God will provide. I'll pray for you after this session. God will provide. Try and eat too. It's very important. It's very, very important. Even though biochemically, once in a while it's good to fast. For real. Do you understand? For real, once in a while it's good to fast. because most of the time we begin to see that there are, let's take for instance, when you try as much as possible to fast, it helps your hormone to be active. Are we there now? If you see an obese individual, an obese individual, when they are breathing, you hear the sound. Are we together now? If that obese individual can try as much as possible to stay for long without eating, undergo exercise, try as much as possible to engage in a bit strenuous activities, they can, come up to date with being healthy a bit. Do you understand? And so, even you that is not obese, once in a while you can go on hunger strike. Not like 7 days, no, that I'm not advising you on that. I would then, so you can try as much as possible to maybe stay maybe for a bit, maybe 6 to 12 p.m. most of the time. You can do it thrice a week. It can be a routine for you. Do you understand? Nothing is going to happen to you. It tries as much as possible to, help you to stay awake, help you to be active more. Are we there now? And try as much as possible to make you to be alert. So being hungry once in a while is part of life. It's not the end of the road. I can come, I'm coming. Now I will send the address. Remind me. So generally, these are some of the things that we need to actually do as much as possible to understand. Carbohydrate is an important biomolecules. Are we there now? Carbohydrate is an important biomolecules that we need to, put into consideration when we're studying about, the body of a living organism. For those of you that will be studying medicine, maybe after biochemistry, or tomorrow you would like to study medicine in the university, you begin to see that, you try as much as possible to look at, the total system of every living organism. Where you begin to look at, okay, say for this particular individual, I want to look at what is their body makeup, and then the individual come and then they tell you, say they have diabetes. Are we together now? And then you begin to say, you have diabetes and your skin you've bleached your skin already. It will really affect you. Are we there now? So understanding this biomolecule, try as much as possible to help us know the life choices that we'll, take, help us know the, decisions that we'll make, the things that we'll make that can, make or mar our life, style and all. So in our next conversation, which will be next week, Saturday, same time by 12 p.m., we'll be trying as much as possible to focusing on protein. I will focusing on protein. And then in that conversation, I will explain to you, why protein is also about molecules. And then we'll begin to look at what we call, the monomer of protein, of course, monomer of protein, amino acids, and we'll look at the polymers of protein. We'll look at them, and I will show you the simpler structures. I will then add some amino acids that makes up a protein. Generally, we have essential and non-essential amino acids. Are we together now? But as we go, higher in this study, you understand why some amino acids are essential and why some are not essential. It doesn't mean that they are not important in the body. It doesn't mean that they are not needed. It doesn't mean that they are useless or what. Are we together now? So those are some of the things that we'll look at. So if you didn't watch this video to the end, go back again, go through this video. Don't just watch to listen. Make sure you have a book, write it down. No knowledge is a waste. Not because I'm not studying biochemistry and then you say, I don't want to learn it. Learn it. Are you there now? So far as you're a life science student, you'll be doing life science. You need biochemistry. Are we there now? Today or tomorrow? So please, try as much as possible to engage yourself. And then this is a lovely week, a lovely conversation. Chris, Salome, Bex91, Robert, Gemma, Clark, thank you all for joining. Thank you all for having this conversation with me, not making it lonely for me. Are we there now? So thank you again. I will see you again next week. I'll be uploading a video here on Monday on the channel. Are we there now? We have a new video that will be coming to the channel on Monday. Undergraduates have been asking me, okay, what are the study habits that can prevent them from having a bad grade, or study habit that keeps their grade poor? So I've already prepared the video. I will upload it on Monday, so stay tuned. By 12 p.m. on Monday, the video will be live on the channel, so try as much as possible to watch and share with your friends too. Thank you all for being here, and have a lovely weekend. Make sure you guys eat, please. If you're not eating, make sure you go and eat, please. I'm begging you in God's name. I will there now. Thank you for your time. Bye.